Whenever we talk about number of solutions between a parabola and a straight line, there can exist one solution, which means the two graphs can intersect at one point, or there can exist two solutions, or there can exist no solution. No solution means the graph will never intersect. So in that case, what I can say is, so whenever the graph touches it, so which means the straight line touches the curve. So we say the straight line is a tangent to the curve or a parabola. So this happens only when your discriminant is equals to 0. And the discriminant is nothing but b square minus 4ac. And whenever the discriminant is greater than 0, after finding the solution in a quadratic equation, so in that case, it will have two solutions. And whenever the discriminant is less than 0, so we can say there is no solution between a straight line and a parabola. So if I take an example of that, let us consider a quadratic equation. Let's say I have f of x, which is a quadratic equation being x square plus 4x plus 4. Let this be my f of x. And I have my another graph, let's say g of x, being, let's say I have something like x minus 4. So now I want to check between these two graphs how many solutions there exist. So in order to find that, the one of the best way that what I can do is, so I can think about substituting and find the point of intersection. In order to do that, I can substitute, let's say this is nothing but y equals to x square plus 4x plus 4, and this is nothing but y is equals to x minus 4. I can substitute that. So it would be x minus 4 is equals to x square plus 4x plus 4. So in that case, if I take all the terms on one side, I'll be getting something like x square. 4x minus x would be plus 3x, and 4x plus 4x would be positive 8. And this is equals to 0. This is the quadratic equation I got it. So after solving them simultaneously. So now if I want to check it, so at how many points these two f of x and g of x will intersect. So I can think about finding the discriminant of this. So if I compare with my general expression, which is ax square plus bx plus c, I can simply say in place of a I have 1, and in place of b I have 3, and in place of c I have negative, I have positive 8. So discriminant is nothing but b square minus 4ac. So b square is nothing but b value is 3, so which is 3 square minus 4 times, and the value of a is 1, and the value of c is 8. And if I simplify this, this is going to be 9 minus 32, and 9 minus 32 would be, let's say, the 9 minus 32 is going to be 23, or negative 23. So since the discriminant is negative, which is discriminant is less than 0, if I plot these two graphs on my xy plane, it will never ever intersect. If I take another example, let's say I just alter few stuff here. Let's say instead of positive x square, let me consider this time I have a negative x square. If I have a negative x square, so in that case, when I equate both, so it has to be, let's say, x square x minus 4 is equals to negative x square plus 4x plus 4. So if I take all the terms on one side, it would be negative x square plus 3x plus 8, and this is equals to 0. Now, if I think about finding the discriminant here, which is b square minus 4ac, so in place of b, I have 3, so which is 3 square minus 4 times, and in place of a, I have negative 1, and in place of c I have 8. So in this case 3 square is 9, and this is minus into minus plus 32. So 32 plus 9 is positive 41. So in this case I can say the discriminant is greater than 0, which means these two lines intersect at 2 points. So this is how I can find the number of solutions between any two given graphs. If I talk about nature of roots of a quadratic equation, let me think about a quadratic formula which goes something like x is equals to minus b plus or minus root of b square minus 4ac divided by 2a. Let's say I have a quadratic equation, some random quadratic equation, let's say ax square plus bx plus c is equals to 0 or something. So in this case, if I want to find the roots of this quadratic equation, so I can substitute these values here. Let me think about some random numerical. Let's say in the first case, I have something like x is equals to minus 2 plus or minus root of, let's say b is b is 2 for sure. And let's say a and c is 1. So in that case, I'll be getting 0 here. And divided by, since let me take a as 1, so if I simplify this, so minus 2 plus or minus root 0 is 0 itself, and divided by 2, this will give you only one answer, which is minus 1. Note this. Let me take another example. Let's say now this time I have something like minus 2 plus or minus root of, instead of 0 I have 100. Let's not worry about what is the exact value of a, b and c. Let's say I have 100, something like this. Now if I simplify this, plus or minus of root 100 is nothing but positive 10. So in that case, there are two cases, minus 2 plus 10 over 2, or it can be minus 2 minus 10 over 2. So in that case, it is positive 4 or negative 6. So here you got two solutions for this quadratic equation. So this is case 1 and this is case 2. Let me talk about the third one. Let's say instead of positive 100, you have something like minus 2 plus or minus root of negative 100. Not only negative 100, it can be negative 1, negative any negative number divided by 2. So obviously, this root of any negative number is imaginary. You cannot have the real value for that. So in this case, you cannot say the roots of the quadratic equation. So here I can say there is no real root. So all these roots of the equation, whether I can have only one root or two roots, or I can say no roots. This depends on something inside the square root, and something inside the square root, which is nothing but b square minus 4ac. And this b square minus 4ac is what is known as discriminant of your equation. So which means the nature of roots depends on the discriminant of the equation, which is b square minus 4ac, as we saw it. So whenever the discriminant is greater than 0, we had a root of 100. And in that case, I got roots are real and distance. Both the roots I got it something like positive 4 and negative 6. So I got two different roots, and which are real numbers. And whenever the discriminant is 0, then my case 1, the roots are real and equal. I got only one root. So which means both the roots are like, say, I can say minus 1 and minus 1, which are basically real and equal. And if I talk about the third case, I had root of negative 100. So in that case, I can say non-real root. So always, to find the nature of roots, it always depends on the discriminant. Now, if I think about how the discriminant is going to affect the graphs. So whenever I plot my graph of a quadratic equation, it will be a parabola for sure. So in that case, so whenever a is positive, it's going to be concave up. Whenever a is negative, it's going to be concave down. So whenever now discriminant is greater than 0, so discriminant is greater than 0 means it will have two roots, or you can say real and distinct roots. So which means the roots of the equation is nothing but, you can also say the roots of the equation is also same as x-intercept of the equation, as you can see it here. So in both these graphs, I have two x-intercepts and both the x-intercepts are different. So whenever the discriminant is greater than 0, the parabola intersects the x-axis at 2 points. Now, whenever the discriminant is equals to 0, the graph, you can say the graph touches the x-axis at exactly at 1 point, as you can see here. So this is real and equal roots. The number of roots is exactly 1. So there is only 1 point. And now, finally, if I talk about the discriminant as being less than 0, so less than 0 means there is no x-intercepts. So that is the reason, as you can see the graph or a parabola does not touching or intersecting the x-axis. So in this case, I can say there is no real root. Now, if I take an example, let's say I have 2x squared plus 4x plus 18. So now if I want to find out the discriminant of this or the nature of the roots, so in order to find the nature of the roots, I can simply find the discriminant. The discriminant is going to be b square minus 4ac. In that case, in place of b, I have 4. So which is nothing but 4 square minus 4 times 2 times 18. So 4 square is 16 minus 4 times 2 is 8 and 8 times 18. So obviously when you simplify this, you will be getting some negative value. So which means the discriminant is negative means this particular equation will have no real roots. So that is how you can solve anything related to the discriminant.